Hello. So here we are discussing about C implementation of Heap. If it is a continuation of previous video, so in my previous video I have described how to write a code for creation of Heap. Suppose a number of elements are given which are stored in a one-dimensional array. So we convert this that can be considered as a binary tree, that one-dimensional array, and we convert it to a heap. So for that we write a program and we use a function create heap which will convert those binary tree into the heap structure. Now we want to get a sorted array. For this example, we are considering an array which will be sorted in ascending order, and the technique is to be used by the technique was implemented by using heap structure. So that sorting technique which uses heap to sort the array is called heap sort, and there are two phases of this heap sort. One is called create heap. Next case is to after creation of it, the maximum value, the maximum element which has the maximum value, that will be in the root of the heap. So we now this suppose the array size is of 10 elements, then root will contain the highest element. Then we will delete this root element, then there will be a tree which will be of the remaining 9 elements. Now these 9 elements, again we convert it to a heap of these 9 elements. So again the root will contain the highest element among these 9 elements. So again I will delete the root and we will consider the array of 8 elements, and again we will convert it to a heap so that the maximum root will contain the maximum value among these 8 elements. So in this way the total array gets sorted in ascending order. So the first phase is how to create a heap when there is within one-dimensional array. So I have converted it to heap using create heap function. Now we will in this heap the root element has the highest value. Now we will delete this root element and remaining 9 elements again will be converted to heap. So this process, how to do this by or what code will be written for this task, that I will discuss now. Deletion of the root element and the remaining elements of this heap will be again converted into a heap structure. For that, among this remaining elements which has the highest value, that will be again shifted to its root of this reduced size heap. Okay. So we will discuss how to do that. So I'm going to the program cd and created heap sort dot c. So we did the programming right there. Now here one thing we will do, the main function as it says, first this will create the original array which is not in sorted order. Then create heap will convert this array into a heap. Then this heap structure, what we have created, that will be again printed. That is the array after converting it to the array is again reflected. Okay. Now we will do the deletion of root element from this state. So how we can do it? Now here one thing is that to delete the root element, what we will do? So if we go to the element, so when this is the element which is stored in an one-dimensional array, which will be sorted. Now after creation of Heap with this element, the maximum value is 90 that we come to root position of the heap. That means this one first index of this array will contain 90, that is the root element, and the remaining will be remaining 9 elements will be there. So for example, if we run this program, then we can see, okay, cancel. If we run this program, we can easily find out what is the after creation of it, how it looks. Oh, we are comparing this on it should be so on to it all. See, and then now I'm running the program. See, so after heap is created, we will get the array like this. So the first index, that means index 1, will create the maximum highest element, and the total this array is a heap. Now what I will do, this maximum index element will be replaced with the highest index element. That means 3 will come here and this 90 will go here. Then I will take the array of whose size will be 1 less than the previous size. That means after swapping this value between 90 and 3 will come here and 90 will go here again. So that will not be a heap in that case. So okay, first let us see if I swap the value, so how it looks. So for swapping purpose, I am using temporary variable, third variable, 10. And here what I am doing, so always as it is a max 6, so root element is at node index 1 of the array. So I am storing this index 1 element, that is root node, which has the highest value in this 10 variable, and we are placing the highest index element, which is suppose here it is array size -1, array size -1, and then this is size -1 was to 10. So that then what will be the structure that I want to see, then it will be okay. So what I have done, I have just swapping. So here I am writing printf after swapping root with the highest index element, with the highest index element of array size of array size. And what is the array size? Which is 10 here. That means so the array size will equals to of array size percentage d. Here it is array size -1. So let's see how this output will be generated. Okay. See, the heap was like this. That is 9057. This was heap. Then after that, after swapping root, that means 90. No, root is the 90 with the highest index element of array size 10. Now this is the array of 10 elements. So highest index element is this. So these 3 and 90 are interchanged. So after interchanging the positions, I have spin the array will be like this. Now what I will do? Now I will decrease the array size by 1. So I will consider only this. Only these elements of the array, because 90 is highest element among all those elements in the array, and that has been placed in the highest index. So 90, so highest value has been placed here. Now we will consider the remaining 9 elements, this 9 elements, okay, remaining this 9 elements. Obviously this is not a heap, so I will convert these 9 elements into a heap. So after conversion of it, this 57 is the highest value among these 9 elements that will from this position, 57. So when 57, that means the highest of this 9 element, highest value of this 9 elements come here. So again we will replace this with this element. That means this index this will be 9, will be interchanged with index this is equals to 1. Because index 1 will contain the highest, so 57 will go to the index value 9, and which is the next highest value after 90. So after then again I will use the array size of this, and I will convert it to heap, and highest element will be there at index 1, and that I will shift it to the rightmost of this parent array. So in this way, if we do, then total array will be sorted. If we do for every position of the array, and ultimately we will get a sorted array. So first of all, we will now this after swapping this the array size. What was the previous array size? Now array size will be -1 of that. So we will construct a heap of this reduced array size. So how to do it? Okay. So here what we will do, we will now every time the array size is getting changed, so I am declaring here a current array size, a variable, global variable, current array size, and its value initially is array size -1. That means the highest index of the of the original array, size of the original array. And while creating a heap, I will use this value, current array size, so that when array size is changed, according to that this value will be changed, and according to that up to what is limit the array operation to be done, that is to be fixed, that is to be found. Okay, so here instead of array size -1, create it, which I wrote previously, I am using the new variable, which is current, CORRENT, current array size, not -1, because already current array size equals to 10. So right child will be the current array size, and here wherever there was array size, I will replace it with the variable current array size. So, and this is now this function is for I already discussed that when parent node, which is a child of a parent node has less value than its child, then child will go to the parent position, that is it will be up of the tree, and the parent who has the less value than its child, that will make down to the tree, that means that will come to the child position. So this interchanging will be done. So when now what is the current child, that is will be again checked with its child, or it will go on going on down to the array, down to the heap, to find out whether to ensure that all the elements of the all the root of the all the subtrays contain the highest element, then it's right. Then it's children. Okay. So what I'm doing this when we continue in the next part. So it was should be unnecessary lengthy. Okay.